Okay, we're going to get started. Thanks for coming to this weather briefing by committee. It was kind of a last minute thing. We have Sarah, anyone wants to jump in. We're covering this historic event here today. We were all watching this anyway, so we figured we'd geek out with super deep crowd. As many of you know, this is a historic storm with 175 knot surface winds at the 1 minute average estimated, which makes it an all-time record for the area of responsibility for the Hurricane Center. And there's nothing on record globally with that kind of wind speed either, although it gets more controversial with the satellite estimation. And we just had Recon go through the storm, and the new estimate went from 880 millibars down to 879. So just taking a quick look at the overall situation, we have two powerful tropical cyclones in the Eastern Pacific. This was a Cat 4 out here, Olaf, in case you heard about this. It's Category 3 now, heading off in the cooler SSTs, and then we have Patricia here impinging upon Mexico. So it's been a very active season in the Eastern Pacific thanks to El Nino. We've had 9 storms that have achieved Cat 4 to Cat 5 status, which is an all-time record. The last time it ever got close to that was 1997 when it produced 8 such storms, and a lot of them in the Central Pacific as well.
That was also the year of Hurricane Linda, a storm which this storm is being compared to quite a bit. Yeah.
So we'll first look at the intensity, which is remarkable. This is the CIMSS ADT graph. Went off the charts. We had almost an 8.5, 8.3, I think, or something.
What is ADT?
Advanced Dvorak technique.
So that's a satellite-based estimate based on the presentation of satellite, which people in this room could explain way better than I could.
But the reason it stops there is the scale doesn't go above 8. There is no Dvorak 8.5.
The ADT goes to 9, but Dvorak only goes to 8.
So John Knox just posed that this storm intensified 100 millibars in 24 hours, which is 4 times faster than baseline for explosive storm growth in low pressure regions of the mid-latitudes.
Yeah.
100 millibars in 24 hours.
Yeah, so you can see the rapid intensification in this ADT numbers and wind speed estimates. This is on the 22nd, we were down to 65 knots, and then by the 23rd, we're all the way up to a Category 5 almost. Now we have an F5, EF5 tornado strength winds in the surface. Yeah. Here's the SATCON. It has a variety of satellite products in it, but it's really not that useful because a lot of them are based on the microwave imagery, which underestimates the strength. The best thing to look at is ADT, which is closest to the Recon.
ADT is doing a great job there.
Yeah.
I'll just note that these black dots here, if you can see them, are the subjective Dvorak from the agencies. So basically, there are 2 agencies that are doing intensity fixes, and so those are shown in the black dots. Even they were on the weak side for this storm because of the rate of intensification.
Well, they have to be.
They have to be because of the rules.
Because the Dvorak technique does not allow for them to break the rules unless they explicitly define it. And by doing that, I mean, it just doesn't, the technique just doesn't allow it. So, but the ADT doesn't necessarily adhere to some of those rules that the Dvorak has in it. So it's allowed to break the rules. So it can go, it can intensify faster than the actual Dvorak technique that's used subjectively.
Right. So the reason that that's important is that the Hurricane Center normally would be kind of beholden to that. They would have to kind of stick to these estimates, but because they had aircraft data, they could ignore that and say, well, we have aircraft data, so we're going with that. So
yeah, so that's the black line.
So that's the case with the Hurricane Center. The reason that that's important is when we compare these storms to other storms in other ocean basins, they don't have aircraft data, and sometimes they stick with the Dvorak method, even though they know that this methodology sometimes can be weak at times in these really rapidly intensifying storms. So in a little bit, I'm going to show some comparisons to other record type intensity storms.
Should we bring that up now, maybe, since keep it
relevant?
with the flow of things?
Yeah, sure, why not? So just bring up.
And then we'll go back to.
Just go to the final slide.
Yeah.
All the way down. There should be a slide below that.
Yeah.
That one. So this is just kind of a representation of some storms that are in the database that are comparable to Patricia. What I don't have up here is Tip. I don't have a Dvorak image for Tip, but Typhoon Tip is the record holder for lowest pressure of any tropical cyclone at 870 millibars. And that was actually measured by aircraft. So we have some confidence in that value. The wind estimates for that typhoon, no idea. We don't know what they are because the aircraft data from that period is unreliable in terms of the winds, but the pressures we're fairly confident on. Botha was a storm that looks very similar to some other storms that are of this intensity. Haiyan, remember in 2013, we had Super Typhoon Haiyan that made landfall in the Philippines, got a lot of press because of its estimated intensity. These are all essentially T8 to T8.5 tropical cyclones in the Dvorak world, which means that they are all at the upper end of the scale of intensity. Probably all in the 800 millibar range, so 870 to 890 millibars. Some of them we know the intensities for. Maggie, actually, we flew this storm in 2010 in a research campaign out in the Western Pacific for ITOP and measured a pressure of 890 millibars. Obviously, Patricia, which of all these storms looks kind of the most ragged, right? It doesn't look quite as impressive. The cloud top temperatures aren't quite as cold. They aren't quite as close to the eye, and yet we measured a pressure of 879 millibars, possibly lower, we'll have to see. Otherwise, these other storms, Typhoon Angela, we suspect could possibly be the most powerful typhoon ever because we were able to get Dvorak numbers of 8.5 to 8.6 for that storm, but we have no aircraft data, so we don't know what it really was. All we know is that it looks more intense than all of these, so based on the satellite alone, it's probably the record holder, but we'll never know for sure. So that's all I have for that for now.
Did you want to show this too?
Yeah, so this, I just kind of put a quick list together. This may not be entirely complete, but kind of in order of intensity. So Typhoon Tip is at the top for a pressure of 870. Again, that was based on observations, 1979. Angela and Typhoon Gay possibly were more intense than that, but we have no observations, so we can't know for sure. Haiyan also probably right in that range of that 870, 875 millibar range. Officially in the records as 170 knot tropical cyclone, so one of the most intense, if not the most intense in terms of winds. Again, no idea because we didn't measure them. Hurricane Wilma, everyone's familiar with, most likely 2005, 882 millibars, 160 knots. Gilbert, that should be 888, sorry, that's a typo. 888, 160 knots. And Typhoon Maggie, which I mentioned, measured at 890 and measured winds of 165 knots. So we do have a good idea of these winds because we had drop sondes in the eye wall, and we had flight level winds and SFMR observations. So we are pretty confident in that. The Labor Day hurricane of 1935, 892 millibars, that was based on observations actually in the Keys. We don't know what the winds were, but we do have a pretty good idea what the pressure was. And then Rita and Linda. So notice that Linda is actually pretty far down this list, and yet Linda is the one that we're comparing Patricia to. So where does Patricia fall in all this? Somewhere in the upper portion of this area here. Again, we don't know for sure what these pressures are, but at 878 millibars and 175 knots. So if 175 knots holds up, this could be the most intense tropical cyclone in terms of sustained winds that were actually measured by aircraft.
Cool, thanks. We'll come back to this PowerPoint in a little while. Just to continue on with the current system, Patricia, this is from this morning. We've had several research missions go into the storm, and this is probably updated by now, but this is the 12Z analysis based on flight winds only. And you can see this is from 17 to 17.5 north. The entire intense circulation is pretty compact. You can see you can't even really pick out the strongest winds in this analysis because they're kind of blended out. But the actual 175 knot winds were within this 15-mile wide core. So it's a very small region of very intense winds, like kind of tornadic. This is very similar, if you guys recall, to Wilma. It was a very tight circulation when it achieved its historic state, almost rivaling this one, but not quite. Very similar structure. Not a lot of kinetic energy. Well, I had a lot of kinetic energy, but the kinetic energy got much bigger in subsequent days as the eye got bigger and weaker. Just looking at the structure, first we'll look at microwave. So this is a 48-hour loop. It's the TC Morph product. You can see how small the inner core is, and you can see towards the end of this, appears to be a secondary eye wall forming, but then the latest imagery doesn't really give a clear-cut picture. However, Sarah, you have latest imagery from the NOAA 43, which is currently flying in the storm. And so they have radar imagery of the structure. You can see that
in there.
the secondary eye wall is really starting to show up.
Yep, the P3 is currently located right about here. It did an eye pass around 1730 UTC, and then we're not even quite sure what it did here when it started doing all of its squiggles. But it looks like it could be heading in for another eye pass as they're trying to do these center fixes on the storm.
My guess is that they're out there. They may be doing some rain band structure work out there, so they may be studying the rain bands.
But this is the P3 has a radar on it, and this is the radar view as the P3 was making a center fix on Patricia.
Yeah, so that to me looks like a classic double eye wall structure, and there's undoubtedly a secondary wind max at this point. So just like Wilma, it's going to start expanding the wind field right before landfall, but on the positive side, generally when you're at this stage of an eye wall cycle, the inner core starts to weaken. So I would expect, as far as being at 175 knots at landfall is probably unlikely, but it'll still be probably a very devastating storm with at least upper Cat 4, Cat 5 winds. I won't show that because we just looked at that. In case we're, well, before I go on to the history of this and how the storm came to be, just a few things, just some more eye candy. Here's the latest 1 kilometer visible, showing a nice wobble to the track. You can see how small the eye structure is. Nice stadium effect in there. Beautiful cloud cover. Derek was mentioning the Dvorak technique. So if we look at the actual imagery, you can see that there was some warming of the cloud shield towards the end, although some colder cloud tops starting to appear again.
But that's that's a larger radius, so that's probably the outer eye wall we're starting to see cool.
Yep. Yeah, so what we might be seeing here is eye wall cycle plus the diurnal cycle. You tend to have the most intense convection during the early morning hours overnight. That tends to propagate outward, and then you see a temporary weakening into the cloud shield with these stronger storms. So that could be partly diurnal plus the eye wall cycle. So the outer eye wall is obviously forming and would be expected to show up in the infrared data as well. All right. So how the storm came to be is remarkable, just how quickly it formed. Scott Lindstrom put together this nice 5-day, is it 5 days? Of
I think so.
Visible imagery.
17th to last night.
So you can see 5 days ago, it's just this disturbance. And then in the final couple days, it just really came together really quickly.
We were giving a briefing on this system on Wednesday afternoon. We gave a briefing around 4 o'clock. The system at that point was only 50 knots. And right now it was 150 knots.
Was there any models that were forecasting intensification?
Not like this, but you never forecast a record. So.
Yeah, I'm going to show that in a second, how just how badly.
Yeah, so first we'll look at kind of the statistical viewpoint of it, and then I'll hand it over to Derek for the dynamical models. By the way, here's a loop either done by Scott Lindstrom or Bachmeier, I'm not sure.
That's a Scott B.
Okay, so Bachmeier put together this beautiful loop yesterday of the storm during its rapid intensification. So you can see how quickly this beautiful eye forms during the day. It's just fortuitous that we caught that during the day.
Has anybody posted up that beautiful beer shot?
Yeah, that's on the blog.
Okay.
Okay, so let's kind of review back to where we were. I used Kyle Griffin's nice page here because it allows you to look back at the GFS analysis and backward in time, so we can watch where this storm came from. This is the 500 millibar vorticity. Unfortunately, we don't have a lower level, do we?
Not on this video.
Yeah, probably somewhere out in the internet there is. So we can follow this backward in time to see where it came from. So several days ago, it was just forming off here by the Bay of Tehuantepec. And And so we'll keep a note of this. There was a frontal surge that occurred early this week and late last weekend that sent winds cruising down through the this gap through here, called the Tehuantepec jet. And then if we go back further in time, you can actually trace this disturbance out towards the Caribbean. So it actually came in from the Caribbean. It's hard to pick up on here, but there was an actual wave that it's associated with, and we can see that in different products. So I'll bring those up. This is the Warped or the Mimic TPW product from the 13th through the 15th. So you can see this wave coming in across Central America. And then right here is when that wind event starts to occur at Tehuantepec as this wave starts to move into this region. So that was the crucial genesis period. And if we go over to the CIMSS product on this page, they have a wind analysis estimate of the 850 millibar vorticity. So this is just the last several days. We'll start it here. You can see a vorticity feature with the Tehuantepec wind event, also enhanced by this terrain feature here. It creates positive vorticity, and so this vorticity is being advected into this region. This is the pre-existing disturbance, and if we animate this backwards in time, you can see where it came from. So it appears to be strongly enhanced by this Tehuantepec event. This will be probably highly studied by many people. All right, so before we move on to Derek's analysis of the forecast models, yesterday we did have a run of the ship's rapid intensification index. It's completely a probabilistic based forecast based on environmental features from the GFS analysis and forecast, and also the satellite presentation of the infrared data. And basically, these are just different RI thresholds. For example, if we center in on this 35 knots per 24-hour period, this is what is the probability of the storm intensifying by 35 knots? And the storm at this point was 80 knots, so it was just really starting to take off. And all the models showed upwards of 70 to 90% chance of that occurring, so that's a pretty strong intensification rate. It turned out to be paltry compared to what actually occurred, which is much stronger than that. But this is about the highest I've ever seen these models. For these types of models, this is considered off the charts. Only Wilma maybe produced numbers like this. And so if you look at if you dig in the actual predictors, you can find out why. First of all, the storm was already intensifying rapidly at this point. Over the previous 12 hours, it already intensified by 25 knots. The potential intensity was 170 knots. And the storm reached 175 knots, so it achieved its full potential and then some. The wind shear was low to moderate, 9.5 knots over a 850 to 200 millibar layer. And then if we look at these predictors describing the storm structure, it was very symmetric storm structure. It had a lot of cold cloud tops. The upper level divergence was high. The heat content of the ocean was high. So basically it had everything going for it. Kind of fun to look at the SSTs. This is Brian Maui, who I think works in the private industry now from Florida State, has some nice graphics. He put together these sea surface temperature analysis of the Pacific, actually the globe. Notice where some of the warmest temperatures on the planet are right now. You can see them right where Patricia formed. And it's actually much warmer than the Western Pacific, classic El Nino structure. If we zoom in on that, this is about 31 degrees over a wide region Celsius, which is 1 degree Celsius higher than the previous record high. So this is, in terms of just temperatures, this is off the charts record territory. If we look at the anomaly maps, again, it's classic El Nino structure with this additional warmth up north, which is undoubtedly helping, and you can see how cold the compared to normal the Western Pacific is. And this is the ocean heat content anomalies. Again, very similar. We had some really deep ocean heat content. Carrie Emanuel sent this profile this morning from an Argo float that was near Patricia's current location, or just south of it, showing this deep mixed layer that goes down to 50 meters. Or here's the salinity structure. So really deep mixed layer. And then just in terms of the rest of the environment, this is the CIMSS shear product. It continues to exist in this low shear area as we go forward in time. But you can see its outflow is contributing to high shear to the north of it and to the south of it. It's got nice outflow channels, which are, some of them are being observed by the TCI fielded program. And also we have a trough up here, which will help steer it north and northeast, that you can see in this analysis up to the north of it.
Can I just add one thing? The benefit of standing over here is you can see the water vapor loop, and that trough off the west coast is really really far south for this time of year. I don't know if it's because Olaf pushed up the ridge. You might be able to argue that, but it's got to have a lot of ventilation, and a nice trough like that, and the water vapor is really going to help. So.
That's an excellent point. Olaf, the role it played in this actual storm evolution and its track could be quite significant. So that could be a publication right there, just trying to understand.
So the WB-57 actually will be taking off shortly. Are they already?
Yeah, they already en route.
So they're en route. So the P3 is
Secondary aircraft.
P3 is flying in around 10,000 feet doing its transect, and Sarah just got a note that they had a rough flight through the eye, and they may be assessing their ability to continue to do reconnaissance.
Yeah.
I'm a little curious as to why that would be, because normally at this stage it usually is not that rough. Usually it's in the rapid intensification stage when you get a lot of turbulence. But I don't know, they must have encountered something, maybe a mesovortice or something in the eye wall. In any case, they're doing drop-ons from their flight level, but the WB-57 is going to be flying in at 60,000 feet and doing drops from 60,000 feet. And they're actually going to be focusing on the northwest side of the storm. So they're actually going to be looking at the interaction between the trough and the outflow of Patricia. And one of the goals today is to try to do drop-ons in that area in high definition, basically high resolution drop-ons, dropping every few minutes to look at the outflow structure and how it's interacting with the trough.
That looks turbulent to me. They're flying in that boundary.
Yeah, it's very uncommon though to see them doing that. They must have had a really rough flight in through. I don't know.
How did you say that?
They fly at,
I was talking about the 60,000 feet with the water vapor.
Oh, actually it's not.
It's not at
very rough. It's very quiet up there. Yeah.
The P3 is at 10,000 feet. They fly a little over 3,000 meters. It's actually pinned to the 700 millibar level, which meant when they flew through the eye last night, and I assume again today, I didn't look at the numbers yet, their 3,100 meter flight level ends up being about 2,300 meters, because you lose about a third of the atmosphere underneath you with the storm is steep. So it's quite the vertical dive into the eye.
And given how small the eye was, over a fairly short period of time.
Yeah, do you have the cross section from that, for pressure, temperature, and wind?
Yeah, go to Tropical Tidbits.
It's
Okay.
neat.
Yep.
It's amazing, actually.
On a related note,
And go up.
recon.
Up.
given the fact that the
Just click on
observation
Tropical
station
Tidbits.
in
Take it back home.
Manzanillo is
Oh, it's
still
weird.
actually
Okay,
1,004
just click on-
millibars. The center of the
I don't know
storm
what
is
the
now
deal is with this
879,
browser. Try clicking here.
135 kilometer distance.
Find
Why
a,
don't I try to
find
bring
a
it up on
mouse
the phone?
over, mouse over till you find something.
So it's
Not
not
that.
often you see 1
Mouse over here.
millibar per kilometer as the
Hey, Jared, let's try the
It could
computer.
be we open too many things.
No, it's the browser. I've seen this on this before. It's whatever. It's
We'll try this.
Firefox is fine for me. Are you in Safari or?
That was. Let's try this.
Over here.
So scanning his on the
Tropical Tidbits.
No, it's
Oh, this one
upstairs.
did like it.
Recon.
So I think they
There we go.
this much.
Click on this
No,
right
They're
here.
just doing drops on, as far as I know.
So,
This one.
so this is a cross section of that cross section that the aircraft just made through from the northwest to the southeast. A couple things that are interesting to me. For one thing, you can definitely see the maximum winds, which is the blue line here, very peaked, so very, very small RMW. And really, even though that there's an indication in the precipitation from the SFMR, so these red peaks here are precipitation peaks. So this is showing the secondary eye wall formation in the precipitation field, but it doesn't seem to be showing up yet in the wind field.
That's
So
surprising.
there's a very small area of increased winds there, but for the most part, the structure is very similar to what it was last night. I find that a little surprising. I thought the system would be a little farther along in its eyewall replacement cycle, but
Yeah,
it appears to be just
starting. Yeah, you can
Look
see
at
it.
the lower right figure. Is that the bump that they probably are assessing?
Yeah, you can see it in the flight wet level.
They had
a little
some
bit better.
problem.
Oh yeah.
They got thrown up and down.
So that is
Coming out of the eye.
Turbulence.
Yeah, that does not look fun.
That was
No.
only measured the 191.
That's at least a 3-bagger.
That's a 3-bagger.
good thing Belden's not here. You make it queasy.
I'm not weaker.
Okay. So let's go into the forecast. I don't know, maybe look at the current forecast and then go on to what the HWRF predicted or vice versa. I'll make this brief. Let's look at the track guidance, because I don't know if we really want to look at the extended.
Hey, Madison.
Yep.
Yeah, so that's the GFDL model. I would take that with a grain of salt. Most of the models at least bring it up towards southern Texas. But first of all, before we get there, landfall over this region of Mexico, which has a populated city. What's the name of that city again, Justin? Manzanillo. It's pretty big city. It's right on the coast. I can bring up the terrain if I remember which window it's in. But anyway, the storm will then head up over this high. There's a lot of high terrain up here, so it'll produce devastating landslides, floods, and Guadalajara and some big population centers are located in this region. So this could be a very unfortunate situation for a lot of people, and especially and also Texas. They're already saturated with a lot of rain from previous days. So this will also bring a lot of rainfall to this region. Some areas could easily receive 20 inches of rain, at least a foot. With high terrain, that won't be good.
So with all this talk about the intensity, which is what a lot of people are focused on, the area, the populated area, doesn't look all that populated in this particular area. The main story could still be rainfall.
Yeah. Here's another view of the ECIMWF ensemble showing all the different members. Most of them tend to stay south and then get picked up by that system. But definitely Texas is under the gun.
It's unclear though what emerges in Texas, right? I mean, we're
Yeah.
not really sure. It's almost like Lee cyclogenesis there.
Yeah, it does show some re-strengthening. If it does move over the Gulf again, even though there will be fairly high shear in this environment, there is warm temperatures, so I don't want to.
Yeah, but how much of the vortex is going to survive crossing the mountains?
Not those high mountains.
Yeah.
I'm not sure if Shane is here, but I know FEMA was just activated in Denton, Texas for the flood event.
Yeah, I talked to
Oh,
a friend of mine this morning. I was asking him what they were doing, and he said they're already got a response center set up, and they're already planning for widespread flooding. They've had a pretty good drought this year. The Panhandle's moistened quite a bit over the last month, but I think the precipitation forecasts could be off, especially if there's re-strengthening.
Yeah.
And they could easily have over 10 inches of rain.
You can show that in tidbits if you want.
Yeah. So
Go
here's
up and
it's on the this isn't the rain product, but if I go to precip,
total accumulated,
there we go. That's a good one.
and then just arrow through.
Like this one I have to manually click. What?
Aw.
So yeah, this is over a foot of rain near Houston.
Houston handles water really well.
It's all that concrete and asphalt.
Yeah.
And
Because
GFS.
Alicia, tropical storm Alicia is like the benchmark for that area.
Allison.
I think 18 inches fell with Alicia.
Allison.
Allison?
Allison.
Allison?
Allison.
Sorry, other A storm.
Not Alicia.
So yeah, lots of devastating floods in Mexico and Texas. That could be the big story with this. Hopefully there's not. Hopefully everyone evacuated, because I don't want to hear any stories about people staying there.
And the storm surge should be, there's areas there that are flat. There's agricultural plains in that area.
I need to bring that up. Where is that?
The storm surge could be
Question-
unprecedented.
The question for that is,
International airport is on the beach,
Yeah.
literally on the
Yeah.
beach.
Yeah.
The men's
yeah,
annular
the question there is, what is the
Already
bathymetry?
issued a state of emergency.
I have no clue.
Yeah,
I mean,
I don't know.
I think the bathymetry drops off fairly much.
Yeah,
Does it?
how you
I think there's a
evacuate a place from
Good
200,000.
satellite on you.
Yeah.
Oh, yeah, it will.
Yeah, it's-
Yeah, there you go.
I think the worst part about this.
So you can
storm,
see the
how quickly it
agricultural
just-
light up right now. Go up
Where are
more
you?
north.
The airport is northwest of the city.
I just want to go into
There's
Manzanillo.
There's Manzanillo.
You can see this Bay Area.
So the bay is, that's bad.
Yeah, and this is where 100,000 people live. So, and there's a lot of resorts along the entire coast.
Where's that again relative
Show
to
the
landfall?
airport to the northwest.
That's right in the track forecast.
No,
South or north?
Or maybe it's
it's
north.
no, the
South?
yeah, this is south of the forecasted
Yeah.
track. So
And
I'm
you
just
see
gonna
those
go
little
right in.
Yeah.
This forecasted
Keep
track is
going.
somewhere around.
Oh, that's not good.
Yeah,
Yeah.
that's about where forecasted track is.
Surge.
And Justin pointed out to me earlier that the international airport's right on the beach.
It used to, yeah.
Yeah, it used to be.
Yeah, that won't.
It's
basically a barrier.
So there's that low-lying agricultural land someone was talking about.
That'll run right.
Think
Depending on
about
the
it,
shelf
24
there.
hours ago, nobody in this place knew this was gonna happen. They've had 24 hours at most to get out of here.
Yeah.
It's 3 days to get out of
Yeah.
Miami.
I've driven that area. It takes forever to go anywhere.
Yeah, so there's not gonna be a lot of people evacuating.
No.
so.
No.
Steve Ackerman's wife Ann is there, or is in Mexico, actually, out of Baja, but further north. She's gonna get out, it's like to LA. Yep.
All right. One last thing. I don't want to be sensationalist, but the GFS did produce another cyclone. Oh, there's that other window. Both the ECMWF and GFS in the long-range forecast want to produce another cyclone out here that goes towards the same area.
Really? I saw that it was producing one, but I haven't seen the new one.
Let's see.
Right there.
Yeah, here. I think this might be it.
Okay. Hi.
There it is.
Oh, that's the old one. Maybe do I have an old one here? Anyway, there was another.
The models do keep this area fairly active.
Yeah.
For the next week or two.
I'm not going to even bother. Let's go back to what Derek was going to show now. But if you look at the GFS or ECMWF, there is another
Let me
cyclone.
sit down so I'm not standing in front, if you don't mind. I'm not going to show a whole lot here, but I will show this. This is the intensity forecast guidance. How do I go into?
You're in presenter mode,
Swap displays on the top.
or just get out of presenter mode and do mirror screen.
Thank you. So this is the forecast guidance from October 21st at 6Z. HWRF, probably one of our better, high resolution models for doing this kind of stuff. D-SHIPS would be and LGEM are going to be the statistical guidance, which is kind of the benchmark. But you notice pretty much all of them had the system going up to maybe a mean intensity of about 80 knots, maybe a Cat 1, at the most maybe a Cat 2. And you can see that what verified is nothing even remotely like that. So this just shows that while the models can forecast intensification, the rate of intensification, I think, is something that they really struggle with. This is 24 hours later. So this is just 24 hours ago. So 18Z yesterday, and again showing basically peak intensity of about 140 knots, and of course the system has just kept going right up to 175. One theory as to why this might have been a problem for the models, this is the HWRF representation of the system showing the radar reflectivity. And pressure of 941 millibars, really not that bad in terms of intensification, showing a fairly strong tropical cyclone, low pressure, and fairly strong winds. But the structure, I think, was not handled correctly. So here the maximum winds were 111 knots. So here's that compared to the microwave image, scaled to the same time frame as the HWRF representation. You can see that the inner core structure of the HWRF is fairly broad. Simply could not accurately capture the tiny wrapped up inner core of Patricia. So the system wrapped up, the eye contracted much more to a much more small diameter than any of the models could show. Could be a resolution issue. This isn't my area of expertise, but
Or initialization.
could have been initialization issues. I noticed that the GFDL, so the kind of funny thing about this is that the GFDL model is also a model that we look to for this type of forecasts. And all season long, it has been out to lunch in terms of way too strong, way too strong, way too strong. So we started ignoring it. And then it started showing this system way too strong. So we're like, well, it's probably not going to do that. So actually, when it initialized at 880 millibars. So maybe their initialization might be a little bit better. But at that point, the storm was already at its near peak intensity. So I'm not sure, but you know, it definitely looks like the structure was very important for getting the intensity right here. These very, very small-eyed storms, the warm core is basically constrained to a very small area horizontally.
What's the radius horizontally?
The eye of this storm is about 11 kilometers in diameter.
So each wharf is
Is it 4 kilometers?
4 kilometers.
2 kilometers.
2 kilometers.
So you're not resolving.
Yeah, you're not
Yeah.
resolving. You're not even resolving 10 kilometers.
Right. Yeah, I mean, 2 kilometers is their new upgrade this year, but it's still not good for this
Not
kind of storm.
resolving 10 kilometers.
It's great for Westpac storms.
And the radius of
Thank
max
you, guys.
winds, I mean, the diameter of the maximum winds and the gradient in the eye wall is, again, probably very problematic for the model.
Yeah.
So these types of storms, which, you know, Patricia, Wilma is another case. Wilma looked very much like this at this intensity. Is still a problem for the dynamic models, you know, trying to
How
resolve.
do those models take into account the ocean surface and the ocean, the depth of that, the warm water?
They just use a skin temperature, I
Okay,
believe.
well, that could be part of it too.
Yeah, they're not-
taking in that.
Yeah, they're not coupled.
Clock of
So
D content, and they're not seeing it. I mean, the sea surface temperature are off the charts, but that's a
Yeah.
lot of energy.
yeah. So I don't know in terms of how they deal with upwelling. Yeah. So COAMPS, which of course is a coupled model, is working on that, but they still haven't. They're not there yet.
I wonder about the vertical structure of the environment, the pre-hurricane environment with El Nino. You know, height of the boundary layer, how well mixed the boundary layer is. I mean, I wonder if it's a little lower than usual, or maybe the other way. I don't know. But if the vertical structure of the atmosphere is in sort of anomalous, is there any data to look at that?
We don't have a lot of data there.
Yeah.
I mean, so one of the things that we can do though is
And
that
the model might be confused about that too.
normally the G4 would be flying a storm like this. If it was in the Atlantic, the G4 would be flying and doing dropsondes in the environment. And those dropsondes are assimilated by the global models. But the G4 was not available. I think that they were doing some radar work, and they were also being potentially tasked to go to Hawaii because Olaf, there was a period of time where Olaf was potentially going to threaten Hawaii. And so they were tasked to fly out there, and they just were never tasked to fly this storm. So that's one way we can get observations into the models is to task the aircraft to do these environmental flights and do data simulation of the dropsondes in the environment. And the inner core as well, if we get the inner core dropsondes, which the WB-57 can do. But right now, the WB-57's dropsonde system is experimental, so none of the global models are assimilating any of that data yet.
Do they simulate the
any
P3?
passes with the
P3,
new
yes. And the radar
NASA
too.
Japanese
HWARP, I think, assimilates the radar.
moisture satellite?
Snap.
Not Himawari, the polar one.
Snap.
Yeah. That would be pretty neat to have a cross section. Of course, it's a crapshoot whether or not you get in orbit.
Okay.
So is that aircraft is circling there? So they're still assessing what that turbulence
A
thing?
message that just came through. When we do field experience like this, there's like a chat thing that you just can't see out this window, but I'm following it on my computer. Someone asked if the P3 is having safety concerns, and the response was, I don't think it's safety per se, they just had to clean up the cabin. So they're also trying to get the vortex data message out.
Wow.
But as the flight director said, we were taking a beating, so.
Okay. So that's all I have, unless anybody else wants to look at anything else. Anybody else have anything? Kyle, did Kyle have anything he wanted to show? Or?
I don't know, he's in
He's gone.
telecon right now.
Oh, he's in
He had a meeting at 2 o'clock.
All right, well, that's all we got then.
Yeah,
Thank you for attending.
Thanks for coming.
All right, we should bring up the CWF on grammars. I just want to see what it does with that.
Thanks.
What the.
I know how to dress for weather.